Hi everyone. We're going to walk over the problem. Let's first understand the problem statement. So the problem statement is saying we have a string S of lowercase English, and we can insert the letter M anywhere in the string, and each insertion costs us 1 point. The goal is to make S a palindrome with minimum number of costs. So first of all, what is a palindrome? So a palindrome is a string that reads the same backwards and forwards. So let's have some example and that manually walks through how does each sample cost you the coin. So if I have a string, let's say mom, it's already a palindrome. There's nothing you need to modify for mom. Or in another example, let's say man, this is also a natural palindrome. What are the palindrome that might needs modification from us? Let's say in the example map. So is there a way we can modify this map into a palindrome based on the problem statement? So here you can try to insert the M anywhere in the string. It's not going to work. So the main problem is that even though we're allowed to insert M in the string, but we're not allowed to magically create other letter besides M. Because in a sense, even though I can put an M here to match with the first M, still these two letters A and P, they need to match. I'm not allowed to magically create an A. I'm not allowed to magically create a P in this string. So this is not allowed inserting other letter besides M. So this map is impossible. But what other cases that can actually work? It's the sample input moon, right? Now with this moon, I can insert an M in the back. Now it becomes a palindrome. So what is the key observation here? The key observations are it's impossible for us to correct matches that are other letters besides M, since we can only create or insert M inside the strings. And if the characters are already a match, then that's great. I mean, the character from front, the character from back. If we go through the palindrome from front and back, if the letters already match, then ignore it. But if they don't match and none of them is M, there's impossible to save it. However, if they don't match, but one of them is M, then it's possible that we can insert an M on the opposite, and then we can move on forward for the inner part of the characters for the inner part of the string to see if there are future mismatch we can create. So how to solve the problem on paper? So let's develop our algorithm in plain English. I have write out the script. So the core insight is that we need to check if the string can become a palindrome by comparing position from both ends. So let's create two pointers. The left pointer starting at position 0, the right pointer start at position -1. And they are both moving forward. So the end condition is that when my left pointer is still less than my right pointers, there are 4 cases I should be considering. The case 1 is the easiest one. When they're already matched, then move both pointer inwards. I'm checking future pairs if they match or not. Well, the case 2 and case 3 are symmetric. So they are both fall into the basket of one of the pointer is M, the other is not M. Now for the pointer that is not M, we can insert M on the right hand side to balance out with the position that already have an M. So if you're at left pointer that's already M, your right pointer is not M, then insert to the right of the right pointer an M and move your left pointer inwards. On the other hand, if your right pointer is an M, your left pointer is not an M. So let's insert an M on the left-hand side for the left pointer to balance and then move your right pointer inward. Now in the fourth cases is when both of the right pointer and left pointer were palindrome-wise, there are two positions that has to be matched. None of them are M, and they're not a match. there's no way we can save it, then we can have the early termination here for our algorithm saying -1. So we cannot fix it by just inserting an M. When the two pointer meet, we have done finally modification on the original string. We have insert all the M needed. Then we can return the total cost. Why does this algorithm work? Because we have ensured that the potential has matching characters at mirror positions. And we realize we can only fix mismatch if at least one of the position has M. The greedy approach work because at each mismatch with the M, there's only one valid action, and that is inserting M. For other mismatch that are not M, there's nothing I can do, so I can have early termination. The client complexity for this problem is open since we can just go through each part of the array and then check for the mismatch, fix it. If it's not fixed, then I just return -1. The space complexity is O1 since using two pointer and a counter. All you need to do is follow up this straight up logic and implement your code in C++ or Python.